Hello everyone, in today's video I will be going through the 10.2 notes over measuring arcs and angles. Obviously I've already filled in quite a bit of the notes just because there is a lot of writing unfortunately. So I recommend that you pause the video as I get to each section, write down what I have written down, and then play it because I'm just going to be talking through it essentially. So for this we're going to start with our central angles. Also, if you have any kind of colored markers, pencils, or pens handy, I'd recommend grabbing. I'm going to use 3 total, so I would recommend 3, but I know some people don't want that many colors in their notes. But I'm going to color code a lot in these notes. It's really needed. So, central angles. A central angle is an angle whose vertex is on the center of the circle. So here's our angle, and as you can see, the vertex of the angle, that's the bend in the angle, it's where the two sides meet. It is the center of the circle, so that's what makes it a central angle. So let me highlight this angle because a lot of students still struggle with this concept of what an angle is. So many of you look at it and this is what you see when you think of angle. I want you to think more than this. It is the sides that make it, yes, but it's the space in between those sides. An angle is a measure of space. It's not just the parts itself. So that's the angle. And something to know, the measure of the angle equals the measure of the arc. So let's say this angle is 85 degrees. Then the arc is the part in between the sides of the angle, and particularly the points on the angle. So D and F, this is the arc. So since the angle is 85 degrees, so is the arc. We're going to talk about more angles than just the central angles, so this is only true for central angles. Other types have to be handled in a special way. The central angles are pretty straightforward. So just labeling the parts, angle DEF is a central angle. DF, that's right, arc DF, is the intercepted arc, and it is the part of the circle between the 2 points of the angle, the 2 points that touch the circle at least. Speaking of arcs, we're going to dive a bit more into those. So, arcs, they represent the portion of a circle between 2 points. So those sections where we split a circle up into pieces with those points. Without any points, a circle is just a circle. But when we add points in, then we're creating arcs. There are 3 categories of arcs. There's the minor arc, the major arc, and the semicircle. A minor arc is less than 180 degrees. So, DF would be an example of that. Now, what's important to note here is there is a special way to write the name. So when you write the name of a minor arc, you use 2 letters. So in this case, we have DF. So DF, with the arc symbol above it, is a minor arc. It also would have been okay for me to call it FD instead of DF. Now let's take a look at major arcs. So the major arc is more than 180, so it is the rest of the circle that I didn't highlight here. It goes the other way around. There we go. So as you can see, I can go from D to F one of 2 ways. I can go this way along the minor arc or this way along the major arc. I look at 2 very different arcs though, depending on which one I use. To be able to tell the difference when writing out names, since a major arc is a lot bigger, we got to change it a bit so it's not confused with the minor arc. Minor arc we use 2 letters, major arc you have to use 3. So we use 3 letters when naming. So in this case, we have DGF. Is a major arc. Again, you could have done FGD. That would have worked. The only one you couldn't have done is by putting G first or last. G has to be in the middle since it's in between our points, our endpoints of the arc. Okay, last one is a semicircle. Semicircle is a half circle. So both of these are semicircle arcs. I'm just going to highlight the top one. And then that goes with the top of the angle, which we know is 180 degrees. We know this because this is a straight angle here. When we name, it's just like the major arc, you have to use 3 letters. So in this case, I'm going to go the other direction, FGD. Is a semicircle. Alright, so those are the 3 categories of arcs. Before we have any practice with these, I want to show you one more item that's important. The sum of the central angles in a circle, also the sum of all the arcs in a circle. Hopefully you're very familiar with this. If you think about like doing a spin, if you spin or turn 360 degrees, you are going to end up turning in a circle. Hopefully that sounds familiar to you. So by that sense, it's the same thing in math class. A circle is 360 degrees. So with triangles, the number to always remember was 180. In this unit, it's going to be 360 with the circle. Back page. I have 2 examples here that I would like you to do. Preferably, I'd like you to pause the video before I do that. You need to know that's 120. Anyway, I would like you to pause the video and try it on your own, and then when you're ready to see the solution, feel free to come back. Alright, so let's discuss these. Number 1, we know that this angle here is 35 degrees. We need to find the measure of arc CB and the measure of arc CDB. So, CB, I'm going to use my orange. Highlight that. And we can see that it goes with the sides of this angle here. So it goes along here. And this is a central angle because the vertex is on the center. In that case, that makes CB also 35 degrees. So the measure of arc CB is 35 degrees. Now let's switch gears and find the measure of arc CDB. So if I follow the arc C to D, and D to B. When you're marking this up, coloring over it, you're just following the letters. That's all you're doing. So if you're one who struggles to see these kinds of things, I highly recommend color coding for this unit, because what we're doing right now, these are the main concepts and the main types of things you'll be expected to do on your tests and quizzes. Tests and quizzes. So CDB is all of this. That's the angle the degree measure we're trying to find. So with this, we know the whole circle is 360, and it's split into 2 parts, the orange part and the green part. We know the orange part is 35 degrees. So to get the green part, we subtract the orange part from 360 to get what's left. If we do that, 360 minus 35, that gives us 325 degrees. So you're going to use the fact that a circle adds up. The angles, the arcs in a circle add up to 360. You're going to be using that a lot in this unit. let's look at a slightly more difficult problem. We have our circle here, we have the 120, and then we're trying to find these three angles. So, you can find these in any order, and I actually recommend finding the second angle first. So that's where I'm going to start. MLN. Again, just follow the letters. MLN, it's our angle right here. Since this is 120, this is also going to be 120. There is definitely a reason for it. You may or may not remember a little something called vertical angles. For vertical angles to be present, you have to have a perfect X. And when I say perfect, I mean perfectly straight lines, like we do here. They have to be straight angles. So make sure that when you follow the line, it is perfectly straight. It doesn't veer off at all. You are going to see a few problems here and there that will veer off, and so they look like vertical angles, but they actually aren't, so be extra careful with those. When you have vertical angles, the opposite angles are congruent. So this is congruent to this, and then the angle on the left is congruent to the angle on the right. So that's your vertical angles. You got a perfect X, opposites are congruent. So that's how MLN is 120. From here, I can kind of go either way. I'm going to choose PLM just because that's number one. So that angle here. For this angle, what I recommend doing is looking at the circle as two semicircles. So you can choose from a few options. You can cover up the bottom half of the circle. And so you can see we now have just a semicircle with 180 here. You could also cover up this half. Same idea, half, so this is 180 together. I'm going to use the top one. Visually speaking, this makes more sense to me. So again, this is a straight angle. Since it's perfectly straight, we know it's 180 degrees. So if this is 120, this has to be 180 minus 120. When we subtract 120 from 180, we get 60. So PLM is 60 degrees. And lastly, NLR. Once again, we still have vertical angles here because these are opposites. So if this is 60, this is 60. So NLR is a 60-degree angle. One way to check and make sure your work is reasonable is to add all of these together to make sure they do in fact equal 360. I will show you that very quickly. 120 and 120 is 240. 60 and 60 is 120. So 240 plus 120 is 360. Again, you could just put all four of these in your calculator if you like, but I condensed it a bit to make it easier. Make sure you do check, because I have some students from last year who gave me some very outrageous numbers larger than 360, which is not possible in a circle. Hopefully that's for obvious reasons. So make sure you check your answers before you move on. All right, one more concept, and that is arc length. Arc length is very different from arc measure, which is what we've been doing this whole video up until this point. So arc length has a formula. It is L equals x over 360 times 2 pi r. Let me tell you what each part represents. L is the length, arc length, but length. X, I don't want you to think of the x that you always solve for. This x does represent something special, something specific. It is the given angle. And really it has to be a central angle. Lastly, r is still the radius. It was in the last set of notes. R is radius in this unit. Let's do a problem demonstrating how to use this formula. Find the length of arc UT. Gonna highlight that. So as you can see, UT is in between this side and this side of the angle, so it goes with this central angle. Reminder, we are looking for arc length, not arc measure. If this were arc measure, this would actually be a very easy problem. We would just put 95 here, because if this is 95 degrees, this is 95 degrees. There's no extra work. That's not what I'm looking for you. I'm looking for the actual length of the arc. So the difference between the two. Arc measure is just the degree measure of the arc itself. Arc length is, if I were to be able to take this piece and straighten it and measure it with a ruler, how long that piece of the circle would actually be. Since I can't do that, I have a formula I can use instead. L equals x over 360 times 2 pi r. Now we're finding the length of arc UT, so L is what's missing. I'm going to leave it as L equals x over 360. X is my angle. My angle is 95. Over 360 times 2 pi r. The radius is 4. Before I put this in my calculator, I want to rewrite it one more time. L equals 95 over 360 times, I want to rewrite this piece, 2 pi 4. A better way to write that is just 8 pi, since 2 times 4 is 8. Now I would personally go to my calculator. So for that, I have 95 divided by 360. It is best if you put parentheses. 95 divided by 360 times 8 pi. And there's my answer. I just have to round to the nearest tenth. Tenths place is this 6 here. So since the next number is a 3, that's not enough to bump the 6 up to a 7. So 6.6 is the arc length. And then inches. The unit kind of helps remind you that this is arc length and not arc measure, so they are two different things. If you put this in a regular calculator that does one thing at a time, make sure you do 8 times pi. Don't just put 8 pi. That calculator does not recognize this symbol here, this term. You have to tell it to multiply 8 and pi together. Just want to point that out there. Okay, that is all for these notes. If you have any additional questions, feel free to come talk to me, either in person or if you want to send me an email, that's fine too. Otherwise, I hope you have a wonderful day. Bye!